So what I did was I used this right here. That is how I knew that this right here becomes this over here. Those are equal. We can
Add 1 plus x to the other side and then like square root it?
No, I just factored 1 minus x into 1 minus root x times 1 plus root x.
Now I'm asking you, how did you factor 1 minus x to 1 minus root x?
Difference of squares, so, I mean, the pattern is a squared minus, well, x is the, you're asking me, I mean, x is equal to the square root of x squared. Like I said at the start, it's kind of a trick, but
I know that, like, I get that, but I don't get how, like, where did the x, where did the square root come from? Like, I don't get how you.
oh, why did I do square? The reason I did square root is because there's a square root in the given problem.
No, I'm asking you, how did you just put a square root on x? Like, I don't get, just because x equals the square root of x to 2, I don't know.
Because you're trying to factor out and simplify it.
Yeah, I'm trying to make the denominator look like the numerator.
Yeah, that I get. I just don't understand how you got like that as your denominator.
Halfway understand.
So does
Whatever you do to the top, you do to the bottom.
does that make sense?
Yeah, that makes sense. I'm getting like, so you just.
I replaced this, which is here, with that, which is equal to it. I mean, this is 1 squared minus that squared, so a squared minus b squared is, you know, this, I always go back to this pattern of factoring. But I don't think that's actually your question. Like, you don't disagree with me that this is equal to that, do you? Okay, so.
I'm asking you, how did, like the top line of the red, how did you get that to equal the denominator?
So this literally is the denominator, of course.
Well, like, how
That's
did you move
not
that
your.
on the other side of the equation is what I'm trying to ask you. Like you moved it on the other side of the equal sign. How did you do that and then add a whole
So
square root?
what's in the green is a comment that informs changing the denominator from this to that, because this expression is equal to that expression. The denominator, just talking about the denominator alone. I'm not doing anything. The numerator just went from one side to the next. Didn't do anything to the numerator in that green step. So I focused just on rewriting the denominator so that it looks like the numerator. Right. Another example might be this. Let's go from the positive side, x minus 3 over x squared minus 6x plus 9. So another. I'm sorry, I don't know what else to tell you about the previous example. Like I'm running out of things to say about it. I have an idea about the next example I do. I'll do it a little bit differently, see if it makes more sense. But how about this one? I mean, we do what we always do, right? To start with, we try plugging in the number. What happens? 0 on the top, 0 at the bottom, right? But, okay, so it's type 0 over 0. So that means I can't just plug the number in. I have to do some algebra. What algebra would you suggest we do? You're like, well, this one's, yeah, because you're used to polynomial factoring, right? Doing this kind of factoring, it's very unfamiliar, right? I mean, I totally agree with that. Like, this is not something that you may have seen before, right?
I've seen something like that, I still don't understand how you.
Okay. I would, so I cancel, and what happens? I get what? So I still get the 0 on the bottom, right? So what happens? I get 1 over something that's 0, right? Is it a positive 0, so to speak, or is it a negative 0, to speak? I mean, so if I think about this kind of limit, this means x is equal to 3 plus some little positive quantity, right? And so if I look at 1 over x minus 3, what's it equal to? It's like 1 over delta, actually. And so as delta becomes arbitrarily small, 1 over delta becomes huge, right? And so this is what? No. I mean, infinity is the right idea, but not negative infinity. It's positive infinity. Because this becomes as large a positive number as you like as you take delta to 0. I mean, graphically, yeah, go for it.
I noticed it in the old ways, like, I see you guys are flexing the minus symbols in the limit. What did it represent?
I see I have the plus and the minus.
Well, no, it's just like for example, you said the limit of this.
3 with the upper plus.
Yeah,
That.
that what confuses me. I'm just like,
Oh, yeah, well, we need to pay attention to that. That means we're approaching like this. This is what x approaches 3 from the right means. So from the right side. If instead you were approaching 3 from the other side, and then the limit wouldn't be plus infinity because you'd end up with like 1 over minus delta when you went through that sort of calculation. Or if you think about the graph, you get minus infinity, right?
I was wondering if it's the determine the solution of the problem. Like the
Well,
infinity is specified, and will it always be the same?
they will not always be the same. They vary from problem to problem. Sometimes they match up, sometimes they don't. In this case, 0 over 0 worked out to infinity, right? So we've seen it worked out to 0. We've seen it worked out to various fractions last class. Now we've seen it work out to infinity, right? There are other places where it'll go different things from one side and the other, so it won't exist. Anyway, so that's all we have time for today, but I hope that helped with the homework. And I will try to have the next homework for you guys posted sometime soon. Oh, let me kill my camera before I forget.